So here we'll be looking at related rates, and related rates involve two or more variables that change at the same time. These variables are usually related somehow, and this is usually through some function. They may be changing at different rates though, so we need to relate how these rates change. So let's start off looking at an example. So air is pumped into a spherical balloon at a rate of 5 centimeters cubed per minute. So we need to determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeters. So the first thing we have to remember is that the volume of a sphere is equal to 4/3 pi times r cubed, but in this case r is a function of time, so let's put r of t cubed. In our question, we're also given that the rate at which the balloon is increasing in volume is 5 centimeters cubed per minute. So here dv dt will be equal to 5. And now we want to find what dr dt is when r is equal to 20/2, which is equal to 10, where 2 is our diameter. Okay, so let's differentiate. I'm going to drop the subscript s just so that it's easier to write with this pen. So if we differentiate both sides, we're going to get dv dt is equal to 4/3 times pi times 3 r of t all squared, and then we need to multiply by the derivative of r with respect to t because of the chain rule. So this situation is because of the chain rule. Okay, so now we can plug in what we have. So we have dv dt is equal to 5, and that is going to be equal to 4/3 pi times 3. R of t in this case is 10, so we're going to have a 10 here, squared, times dr dt. Okay, cool. So now we can isolate dr dt to find a solution. So dr dt then is going to be equal to 5 over 4 pi times 10 squared, which should give you a value of 1/80 pi centimeters per minute. And that's our final answer, and that's how we do related rates.